Hi friends, good evening. So welcome to the Automotive Analytics training by 360DigiTMG. So yesterday we discussed regarding decision tree. So it is a supervised machine learning algorithm. So today we are here to discuss about linear regression. So today agenda. So we'll discuss about introduction and what is linear regression in machine learning. So how it is important in automotive analytics and conclusion. And so yesterday and day before yesterday, we discussed about classification problems. Now regression is nothing but, so it is very popular, most popular machine learning algorithm. So it is a statistical method that is used for predictive analytics. So this regression, so it is if your output variable is nothing but continuous numeric value, so we can use regression. So it will give the relationship between independent and dependent variable. So one are independent variables versus dependent. So suppose if the relationship between one independent variable and one dependent variable, so that is we can call as simple linear regression. Suppose if the relationship is between one or more independent variables to the one dependent variable, that is multiple linear regression. So it is since linear regression shows the linear relationship, so which means it's find how the value of the dependent variable is changing according to the independent variable. So how the y is changing, output variable we can say here y. So how y is changing by changing the inputs x. No. So the formula for linear regression, so you can see, so y is equal to so a naught plus a1x plus epsilon. So this is the mathematical representation of linear regression. So in above, y indicates target variable. So it is also called as a dependent variable, and x is nothing but predictor variable. So that is called as independent variable. And a naught is nothing but intercept of the line. And a1 is nothing but linear regression coefficient, and epsilon is nothing but random error. So the values of x and y variables are training data sets for linear regression model representation. So you can see this figure. So how the independent variables are, how dependent variable is changing. So with respect to the independent variable. So how the linear regression works in machine learning. So linear regression is a machine learning algorithm. It is, as I explained, it is supervised learning. So it performs a regression task. So this model has a target prediction value based on the independent variables. It is mostly used to finding out the relationship between variables and forecasting. And so we have different regression models, so differ based on the kind of relationship between the dependent and independent variable. So what we are considering, and how many independent variables are we are using. Next. So linear regression. So this is nothing but either relationship between one independent, or one independent, or one or more independent variables with respect to so dependent variables. So we have the types of the linear regression. There will be two types. So first one is nothing but simple linear regression. So simple linear regression, as it indicates, so it will give the relationship between one independent variable and one dependent variable. Then we have multiple linear regression. Suppose if the independent variables are more than one, then we can use. So how the y value is changing with respect to the number of input variables. So now linear regression algorithm, it shows the relationship between the dependent and independent variable called regression line. So regression line is the thing that, so which will show the relationship between dependent and independent variable. So it will be two types of relations. Either it will be positive line. So left side picture indicates so positive line of regression, and the right side picture shows the negative line of regression. So main goal is to find the best fit. That means error between the predicted values and actual values should be minimized. That will give the best fit. Best fit line will have the least error. And let us discuss MSC. So errors in the linear regression. So mean squared error. We use the mean squared error MSC cost function. So which is average of squared error between the predicted values and actual values. So it can be right the below formula. MSC stands for mean squared error, that is equal to 1 by n summation I equal to 1 to n. So yi minus a1xi plus a0 whole square. So here n is nothing but total number of observations, and yi is nothing but actual value, and a1xi plus a0 is nothing but predicted value. Right. Now how we use this linear regression in automotive analytics. So in automotive industry, so keeps track of sales for a variety of personal motor vehicles. Suppose we have historical data. So historical data saying that, so this type of sales, so coming to last 3 months, the sales of a particular product, like, so based on that we can predict, so in next months, so what will be the sale for a particular products. Yeah, so we can predict the sales of a particular type, and in an effort to the able to identify over and underperforming models, you want to establish a relationship between the vehicle sales and characteristics. So which vehicles are performing best and underperforming models also you can classify based on the sales and characteristics. And by using this we can influence the price of the vehicles. And so this is also helpful to predict the life of vehicle by analyzing the other parameters such as engine condition, service of vehicle, etc. So based on this independent features like engine condition, serving of vehicle, mileage, engine size, so we can predict the life of the vehicles. Now it is found useful in regression and predicting model due to the fact that it can tell accurate prediction, and it can handle only continuous variable. So the execution of linear regression can't happen without correct so dependent time, so independent variables. Okay, so this is how linear regression will work in automotive industry. So let us go and let us discuss one practical use case to understand linear regression in automotive industry. Yeah. So as our use cases predict used car prices using linear regression. So the problem statement is nothing but so there will be huge demand for user cars in the Indian market today. And as from some years onwards, the sales of new cars have slowed down, so due to the various reasons. Now we are building one model So pricing scheme of the user cost become, why this user cost becoming important, and pricing model that effectively predict the price of user car and can help business to devising profitable strategies using different pricing. So what should be the price of, used car? We need to predict, as the user cars, the maximum are very interested to purchase used cars. So by this model, so we need to say what should be the exact price of the used model. And our data set consisting of some columns like serial number, nothing but serial number, name of the car, which includes brand name and model name. Next, location, the location in which the car is being sold or is available for purchase. And year is nothing but manufacturing year of the car, kilometer driven, the total kilometer driven in the car by the previous owner. As we are discussing the old cars, just how many kilometers so driven by the car, and what type of fuel and transmission, type of transmission used by car, automatic or manual. So type of the ownership, mileage, standard mileage offered by the car company. Next, engine, so displacement, volume of the engine in cc, maximum power, seats, the number of seats in the car. So new price of the car, which suppose user car price. Now what is the price of the new car of the same model? So what is the new, if suppose same model, if we purchase new, then what will be the cost? And here price is nothing but price of the user car. New price is nothing but new car price and old car price. Yes. So what is the problem? So does vary, so here we have various features. Does various predicting features affect the price of the used car? So is the price of the used car is depending on the features or not? So what all independent variable affect the pricing of the used car? Suppose if you say the output variable is nothing but price of the used car. So how the value, the price of the used car is depending on the other features, various features, what are given. Does name of the car have any effect on pricing car? So is it with respect to the name of the car? And how does type of transmission affect? Is the transmission type is affecting the cost of the used car? And is it affecting on location? Is it affecting on kilometers? Yeah, suppose if many kilometers are travel, then the cost is less, like that. Do we have any relation between that? And does mileage, engine and power, do we have any relation with respect to the cost of that? Next, how does the number of seat, fuel type affect the pricing? So these we need to check. So first, libraries. So we need to import the necessary library to apply this machine learning concept, linear regression. Yeah, import SciPy stars as stars, pandas as PD, numpy, matplotlib for visualization, seaborn for visualization. And these are some particular modules are required to implement this linear regression algorithm. It is done. So then we need try to understand the data. So the data is nothing but user cars data.csv. So if you want to load the data, so you need to use the command. So pd.read_csv. Then path we need to give. Yes. So now this data set has 7,253 rows and 13 columns. Okay. And as we discussed it in the previous class also, so cars.head will give top 5 rows. So the column names are nothing but name, location, year, kilometer, year. So kilometers driven, how many kilometers are driven, what is the fuel type, is it CNG, diesel, petrol, transmission type, is it automated or manual. So owner type, is it is first hand or like second hand. So mileage, engine, power, seats, new price. So new price I have given. New price is nothing but same model vehicle. What is the price now? Price is nothing but price of that old model. Yes. Now bottom 5 rows. So these are the bottom 5 rows. Same name, location, year, kilometer driven. So fuel type, transmission, owner type, mileage, engine power, seats, new price and price. Done. Now try to get the size of the data frame. So print rows. So here our intention is that to get the number of rows and columns and print the features. And missing values, percentage of missing values, etc. So this will give some EDA. So total data set has 7,253 rows and 13 columns. The features are nothing but name, location, year, kilometer driven, fuel type, transmission, owner type, etc. Now let us understand data.info. So here data set is nothing but cars. So cars.info will give the information regarding our data set. So data set has these columns as we discussed, name, location here. So data types of each and every column is given here. So then, so we are visualizing the missing values. See, this is a visualization of missing values with respect to each and every name. So in name, how many missing values? Percentage of missing values, location, year, etc. Now from this, the above one is the thing, but visualization of the missing values. Now from the above graph, it is clear that some observations. So let us discuss about that observation. So this preview shows that some columns are potentially have lot of missingness. So we'll want to make sure look into that. The new price has only 1,006 values, 86% are missing. So out of it is total 7,000, but it has only 1,006 values. So 86% values are missing in the new price. And coming to price, price is our target variable. So price of the user car. So that is our output. So how on what factors the price of the car is depending. So price of the user car. So it is our target variable. 17% of missing values we found. And coming to seat, only 53% values are missing. So we can, it is key factor deciding price. Next, power and engine has 46 missing values, mileage 2 missing values. Mileage, power, engine, new price. We know the quantitative variables, but are of the object type here and need to be converted into numeric. So these are some categorical columns need to convert into the numeric, right? So making the list of the categorical variables. So the categorical columns are nothing but fuel type. Either it is petrol, diesel, CNG, etc. And location, which location the car is from, and transmission type, automotive or manual, seats, year, owner type. Now printing number of count each unique value in each column. So from column in categorical column, so print car column value dot count. So here Hyderabad, Coimbatore, Kochi, etc. So from this we have some observation that maximum car being sold have fuel type of diesel. So maximum are sold, the fuel type is diesel, and Mumbai has highest number of cars available for purchase. So old cars, if you want to purchase the used car, best choice is Mumbai. This is observation. And 5,204 cars with manual transmission are available for purchase. And most of the cars are 5 seaters and first owned, and years of car ranges from 96 to 2015. So these are the observations from above one. And let us go to the data pre-processing step. Only data business understanding, data understanding is done, and we are going with the data second step, data pre-processing. So processing engine power and mileage column. Let us analyze power and mileage columns. So I'm taking random values, random sample 10, the seed is equal to 9. So engine power, mileage. So these are the values, random values. And type of fuel, CNG and LPG. I'm taking only these two and top 10. So serial number, name, location, year. Yeah, only I'm taking the fuel type, either CNG or LPG. So this is the results. So from this, we can understand power has some values in null BHP. So null BHP is nothing but brake horsepower. It's one type of measurement, horsepower. So mileage also have some observations as 0. So for fuel type CNG and LPG, mileage is measured in kilometer per kg, where as for other type it is measured kilometer per liter. Since most units are in kilometer, both of them need to conversion. So dropping units from mileage, engine and power. So we are dropping units of mileage, engine also, power also. So from this, it is clear I have seen some values in power and mileage as 0. So verifying data for engine power mileage, will check once again for converting data type. So cars query power is equal to 0. So 0. So mileage 0, 0. Now converting this observation to NaN, we will remember to handle them when handling missing value. Just I am converting that 0 values as none. So now next I am getting cars and unique. So engine 150, power 385, mileage 437. Now I'm checking, do we have NA values? Yeah, we have NA values are present. Engine 46, power 175, mileage 83. So there are 46 missing values in engine, 175 in power, and yeah, this is the missingness. Now processing the seeds. Now seeds 3,999, 0. So seeds cannot be 0. So changing it to NaN and will handle in missing data. So seeds column default it is giving 0, but it is not, practically it is not correct. So we can convert into NaN. Then we are processing with the new price. So we know that new price is the price of the new car of the same model. 1 lakh. Suppose this column clearly has lot of missing values. So we will impute missing values later. For now, we will only extract the numeric value from the column. So what the numeric columns we have from the column new price, because this is important. That's why. Yeah, the data need processing miss as 1.28. So new price, this is a new price with respect to the columns. So now I am creating one list. So with the name new price name, and I have written for loop for observation in data frame new price if is instant observation string RE match. So I'm using regular expression, so matching object and else etc. And add the new column to the data. Now checking the new data frame. So what is just I'm reframing into the data frame. So top 5 is nothing but, so name, location, year, kilometer driven, fuel type, transmission, owner type, mileage, engine, power, seats, new price, and price, new price now. Now next feature engineering. So first thing is converting into the data type. So converting the object data type into the categorical data type. It is converted now. So cars describe. So it will give some statistical analysis on numerical columns. So year, kilometers driven, mileage, engine, power, seats, price, and new press number. Now processing the years to derive the age of the car. So how we can get the age of the car by the years, processing years. Since the year has 2014, 1996, etc. But this will not help to understand how old are. And it is its effect on price. So creating two new columns, current year and age. So current year would be 2020, age would be the current year minus the previous year. Suppose the current year is equal to 2014. So age is nothing but the current year minus the year of manufacture. So we can get the age. Yes. Now let us, we are adding two columns. So that we can find the age of the used car. So now again, the top 5 rows we have like this. Now processing name column. So brand to play an important role in car selection. So extracting brand names from the name. And before that, just if you have any values, we are dropping. Now, so coming to car, we have different brands. So I want to get a unique name of the brands. So these are the unique names. So correcting the brand names. So we corrected. Then here we can say that brand names like ISU ZU and ISU ZU are same and needs to be corrected. So land mini seems to be incorrect. So correcting brand name. So as the data, some incorrect given. So we need to correct the brand names. So then again, I am getting the information of the car. So cars.info will give the information regarding this. Yeah, most are converted into numeric. Now changing the brand names. So we can change by using cars.log, cars brand. So here the column names we change. Now in unique, so how many brands, unique brands we have? So 24. So now we are grouped by with respect to the brands. I mean, which brands are more? That one I'm getting by the group by function. Ascending is equal to false. So you will get from higher value to the lower value. So like brand Maruti, 194, Hyundai 96, Toyota, Honda, etc. So there are 32 unique brands in the data set, Maruti brand. So is most available for purchase. Now again, I'm checking, do we have any values? So no any values. Drop row with no model. Next. So group by model. So we are group by function we are applying with respect to the model. So the observation is the thing that so there are 726 unique models and Swift Zyre is the most popular model. Now we are doing EDA, exploratory data analysis. Again, I am doing EDA, statistical analysis by cars.info. So different data types, then describe. So it is applying for only numerical column. So count, mean, standard deviation, minimum 25th percentile, 50 percentile, 70 percentile, max. Now the observations. So from the above analysis, so years is left skewed. So years ranges from 96 to 2019. So age of cars 2 years old to 25 years old. Next, another observation, kilometer driven, median is minus 53k kilometer and mean is minus 58. So maximum value seems to be 65 lakhs. So this is very high and seems to be outlier. So it should be analyzed. And mileage is almost normally distributed. And power and price are also right skewed. And price 160 lakh is too much for user car, seems to be an outlier. So there will be some outliers, we need to handle that. Now here we have visualization. So with respect to year, kilometers driven, mileage, engine power, seats, univariate analysis, price, new column number, age of the car. From above, we have some observations. The year is left skewed and has outliers on lower side, and kilometers driven is right skewed. The mileage is almost normally distributed. Engine power and price are right skewed, and age of the car right skewed. Fine. Let us go with categorical column. So we have the category column like location, fuel type, transmission, owner type, and brand. Then we are applying visualizations. So you can see these are the visualizations on categorical column. So we can have the observation minus 71 percentile cars are available for sale have manual transmission, and 82 not minus. So 82% car are first owned cars, and 13% of car available for sale from Maruti Hyundai brands. 53% of car being sold are available for purchase have fuel type diesel. And Mumbai has highest number of cars available. Yes, most of the car are 5-seater, and car being sold available for purchase in 2 to 23 years old, and 71% of car are lower price of range car. Now just analysis with respect to the two columns like price versus mileage, and price versus engine, price versus power, price versus seat, and price versus age of car. Now let us discuss how to handle the missing values. So as per our data set not have any missing values. So to get the missing values, we have this command cars.is and is num sum. But it is saying that there is no NA values. So count the number of missing values per row. So 0. Now let us investigate the how many missing values per row are there for each variable. So this confirms that certain columns seem to be missing together or all non-missing together. So we will try to fill the missing value so much as possible. Now cars missing is equal to 7, so you cannot find any rows. So now we can start filling the missing values by grouping name, year, and fill in missing values with median. So we are handling missing values with respect to the median. Yeah, it is done. And here engine power mileage. So handling the missing values. engine power, mileage. No missing values. So here also done. So we handled missing values. Now the observation is nothing but, as we can see, the most of the model have same engine size instead of just applying median. So grouping with model, and here that should give me more granularity are near to the accurate values. Yes. So choosing median to fill the missing values, as there are many outliers. Yes, engine is done, power and mileage column. Now after checking the any missing values, so it is clear that no missing value present the columns engine, power and mileage. So there will be still missing values. Because we have different various column. So let us check the column names: model, year, engine, median, mean, max, etc. Now we are grouped by brand, engine, power, and aggregating we are doing mean, median and maximum value. So brand order, so median, mean, max. For different engine, so different mean, median, max value. Yes. So BMW and Datsun, Fiat. Now let us checking any NA values in the seats column. So it is saying no NA values, 0. Now let us grouping with name should give the more granularity and near to the accurate seat values. Seat 0. So grouping with model should give more granularity and near to the accurate seat values. And here I am applying lambda function. So it is been discussed already. A lambda function is a small anonymous function. Yeah. Yeah, fine. Now let's check with car types. Have any missing values? No, 0. And most of the cars are 5 seaters. So first fill rest of 23 by 5. Yeah, fine. Next, we need to analyze along with the price. So if the seats play any role. So location, brand, category. Now let us processing the new price. So for better. So here the granularity is nothing but the relative size, scale and level of detail or depth. Now we have new price number grouped by with respect to name and new price number, and again there is no any values present. Same cars new price name we group by with respect to brand and model. So we are trying with different methods. So finally group by brand, so new price number, median with respect to median we can have. Now again I am checking any NA values. Do we have any NA values? Now column names power, mileage, engine, and dropping the remaining columns. Yeah, now we have the columns. Location, year, kilometers driven, fuel type, transmission, owner type, mileage, engine power, seats, price, new price number, age of the car, brand, model, etc. Now, after that new data frame, what is the top 5 rows? These are the top 5 rows. So you cannot see any NA values here. Now, any NA values no. Data shape is 7,253 rows and 13 columns. Finally, done with missing values handling. That is done. Now we are taking brand price, aggregating median, mean, max. Now business knowledge to create class. So low, these values, some pages, some are nothing but high. Now the brand class is nothing but brand, and brand class we are creating. So array it is either low or high. Now bivariate and multivariate analysis. So let us check the plot, how the relation we have between the different columns. And from this, we have the observations. Engine has strong positive correlation to power, and price has positive correlation to engine, and mileage is negative correlated to engine. Price has negative correlation of the age of the car. So kilometer driven does not impact price. No. So pair, this is the pair plot and observation. Same observation about correlation as seen in heat map. Kilometer driven does not have impact on price, and as power increases, mileage is decreases. So car with resale makes sell as higher prices. Engine and power increases, price of the car seems to be increased. Fine. Now variables that are correlated with price variable. So price versus engine versus transmission. Yeah. Now again, price, mileage, and transmission. Yes. So these are the different visualizations. Now need to check the reason for this spike in price for third owner and model N. So the observation is so the one of the car is expensive and luxury car. And again, I am doing statistical analysis by cars.describe. So let us calculating price, mileage, and fuel type. So this is the visualization. Price versus seat, price and location, price and brand. So SNS plot. These are all comes under various visualizations. Now EDA is done. So from this EDA, we have insights. Expensive cars are in Coimbatore and Bangalore, and the cars which has two-seater that are more expensive. So diesel fuel type are more expensive compared to the other fuel type, and expected older models are sold cheaper compared to the latest model, that we know. So automatic transmission vehicle have a higher price than manual transmission vehicles. Yeah, so we have, these are the observations. So let us check the distribution of if skewed. This is the distribution of the data, and distribution to right skewed. So using log transform can help in normalization. Yeah, so this will be done before the data split. Perform log, transform cars, kilometers driven, and price. So we can drop some columns, so which will not give the correct answer. Yes. Now let us discuss about information. Yeah, category integer. Now data engineering step, second stage also finished, model building. So we are creating X and Y. X is nothing but input variables and Y is nothing but output variable. So before that, X is equal to drop price and price log, and from Y we are dropping price log price. So dummy variables we are creating. Now we are splitting train and test. So 0.3 meaning 70% training, 30% test. So X train, X test, Y train, Y test. And here one more, stat model API does not add a constant by default. So we need to add explicitly. Now fit stat model, done. And here we have both R squared so both R squared and adjust R squared are model are very high. And this is clear indication that we have able to create a very good model that is able to explain various in piece of user cars up to 18%. And it is not an underfitting or overfitting. It is a good model. Fine. These are the insight. Now let us import mathematical library. Yeah, we have imported and we calculated RMSC, map, mean absolute error, etc. and model performance on train and test. So these are the values. Data, train test, RMSC, mean absolute error, mean absolute percentage error. Yeah. Train test, you can have the error values. So root mean square error of train and test is not different. So indicating our model is not overfitting on the train data, and mean absolute error indicates that our current model is able to predict user cars prices. And the units of both RMSE MAE are same. So lags in this case. So but RMSE is greater than MA because it penalizes the outliers more. And the mean absolute percentage error minus 23% on the test data. So these are the observations from above. Yeah, so the test assumptions, checking the linear regression assumption, no collinearity, and mean of residual should be 0. Heteroscedasticity, linearity of variables, normality of the error terms. And just we are checking these assumptions, linear regression assumption. Anyway, our model is good. So these are all different assumptions. Yeah. So observations from the model. So it is important to note that the predicted values are logged. Therefore, coefficients have to be converted accordingly to understand their influence on price. So with this model, we have able to capture 89 variations in our data, and model indicates the most significant predictors of price of used cars, like age of the car, number of seats in the car, and power of engine, mileage, kilometers driven, location, fuel type. So based on that, we can get the expected we can get the output variable. So this is linear regression. So this mainly how the cost of the used car is depending on various features like name, brand, kilometers driven, etc. So this is our use case. So once we can revise. Yeah, so today we discussed about yeah. We discussed about linear regression. Linear regression is nothing but giving the relationship between the one independent variable to the one dependent variable, or one or more independent variable to dependent variable. Okay. And thank you, friend. Thank you for joining. And so we will meet tomorrow.